Welcome. This will be a review of the College Algebra Exam 1. For the first problem, we could start off by distributing the number in front of parentheses, and we remember if there's no number, it's automatically a 1. So we get 2x minus x plus 3 is equal to negative 2x minus 4 minus 3. Combining our like terms, we could combine x's here. X plus 3 is equal to negative 2x minus 7. Bring the x's on the same side and bringing the 3 over. Dividing by 3 finally gives us negative 10/3. For the second problem, when we're solving absolute value, we want to isolate the absolute value. So first thing we could do is add 2 to both sides. And then divide by 2. We get the absolute value of 3x plus 1 is equal to 15 halves. And then once the absolute value is by itself, we keep one side exactly the same, and the other side we take the opposite of the right. So if you subtract 1, you get 3x is equal to, this would be 13 over 2. And then if you divide by 3, you get x is equal to 13 over 6. And then on the other side, if we do the same thing and subtract 1, we get 3x is equal to, this would be negative 17 over 2, and x would therefore be negative 17 over 6. Moving down to the second group of problems, we want to write our answer in interval notation. Remember, with interval notation, we're either using parentheses or brackets. Brackets include the value on the inside, parentheses do not. And we're always going to put the low value on the left and the high value on the right. So let's go ahead and take a look at these. First thing we could do is, for the first problem, we want to get x by itself. It's a compound inequality, so we'll subtract 3 from all sides. And then divide by 2. And it looks like x is between negative 11 halves and 13 halves. So the way we would write this is we have to include negative 11 halves and 13 halves. So we would write them using brackets. The problem to the right, we can go ahead and distribute the negative 2. So negative 8x plus 14 is greater than 3x plus 5. Combine our like terms by bringing the 3x over and the 14 over. We get negative 11x is greater than negative 9, or x would be less than 9/11. Remember, anytime we divide by a negative with inequalities, we have to switch the sign. And this would mean any value up until 9/11. So 9/11 would be the highest value, not including it, and then negative infinity would be on the other side. For letter C, absolute value inequality, just like with equations, we want to get the absolute value by itself. Then we could separate it. One side stays exactly the same. And then the other side, we would switch the inequality and take the opposite of the right. We switch the inequality because we're multiplying 9 by negative 1. So we get 4x is less than negative 10. X would be less than 5 halves if we reduce. And then 4x is greater than 8, or x is greater than 2. The way we write this in interval notation is we would say any value greater than 2 or less than 5 halves. So let's see. Less than 5 halves we would write like this. and then greater than 2, we would write like this. If it helps you, you could always draw a number line. And we have 5/2 here. Values to the left of that go this way. And then we have 2 over here. Values to the right of it go this way. And then the last problem from this section, it's an AND problem. And so that means we're going to have to be looking for overlap between the answers. If we add 6, negative 2x is less than 10, so x would be greater than 10 divided by negative 2 is negative 5. Remember, I switched the inequality. And negative x is greater than or equal to negative 4, or x is less than or equal to 4. If we graph this, here's 4, negative 5, we're looking for values in between. We are including 4, we're not including negative 5. One other thing I want to note is with absolute value, remember with absolute value is greater than a number. We call it an OR problem, meaning we're just looking for coverage on the graph. And if absolute value is less than a number, we make sure that we make it an AND problem, so we're looking for overlap. For the third problem, write a slope-intercept equation. So that's y equals mx plus b. For the line going through 3, negative 2, and it's parallel to this line. So parallel means we're going to have to use the slope here. 6y is equal to negative 3x plus 5, and then divide by 6. Y would equal negative 1/2 x plus 5 over 6. So the slope of this line is negative 1/2. The slope of a parallel line would therefore be negative 1/2. So when we go to write this in slope-intercept form, we're going to put negative 2 for y, negative 1/2 for m, 3 for x, and solve for b. Adding 3/2 to both sides. Negative 2 is negative 4 over 2, plus 3 over 2 is negative 1 over 2. And then tying together our slope with our y-intercept gives us this slope-intercept form. For number 4, to get the x-intercept, we make y equal to 0. And to get the y-intercept, we make x equal to 0. Finishing these up, we get 4x is negative 8, so x is negative 2. Label it. And 2y is negative 8, so y would be negative 4. We can go ahead and connect our points. And then to find the slope, we could either rearrange our equation in slope-intercept form, or just look at the graph. Since slope is rise over run, we're going to go up 4 units and to the left 2. So up 4 and to the left 2 would give us a positive 4 or a negative 2, which is a slope of negative 2. And again, we could have also seen this if we just rearranged our original problem in standard form and wrote it in slope-intercept form. So we get the same exact slope no matter how we do it. Moving to number 5, we want to find the midpoint. So the midpoint was the average of the x values, comma, the average of the y values. So if we average the x values, 7 plus negative 3 over 2, that would give us 4 over 2, which is just 2. And if we average the y values, negative 2 plus negative 1 over 2, this would be negative 3/2. To find the slope, we subtract the y values over, we subtract the x values. Remember, it's the change in the y's over the change in the x's. So we're going to do -1 minus -2. And then we're going to put that over -3 minus 7. So my computer just froze. Just give me 1 second to unfreeze it. Okay. And we're going to do -3 minus 7. So our slope would be -1 plus 2 is 1 over -10. For the standard form of the equation of the line, we could use slope-intercept form, pick one of the points, plug in for the y value, the slope, the x value, and solve for b. So if we multiply here, we would get -7/10. And then if we do -2 plus 7/10, that gives us -13/10 for a y-intercept. So in slope-intercept form, we get y is equal to -1/10 x minus 13/10. Standard form, we have to get the x and y on the same side. And then we're going to multiply everything by our LCD of 10. I like drawing arches to make sure I don't miss anything. And we get x plus 10y is equal to -13 for standard form. In order to graph the line, we could even just go to 7, -2. That's the first point, point A. The second point was -3, -1. And then just connect our points. For problem number 6, the jar contains 33 coins and 5 of them are nickels. What percent of the coins are nickels? Well, this sounds like a percent or a proportion problem. So when we have percents and proportions, what we could do is do part over whole is equal to percent over 100. And the part that we want are 5 nickels out of 33. And we want to figure out what percent would that be over 100. So if we cross multiply and use x for the percent, we would get x is equal to about 15.2%. For number 7, the domain would be the x values arranged from least to greatest, so 0 and 1. The range would be the y values from least to greatest, so -8, -7, and 3. And this is a function only if every x value is only going to one y value. So if we were to draw a mapping diagram, we could see that 0 goes to -8, but 1 actually goes to 2 different values. So this is not a function. When we're talking about domain, we said that there's 2 issues that we're looking for. So the 2 problems that we can encounter with domain, one of them is that the denominator can't be 0. And the other thing is that if we have a radical, the inside number, the dividend, has to be greater than or equal to 0. So let's go problem by problem and see what the issues are. For this first problem, y is equal to 1 over 2x minus 5. It has a denominator. So you could use any x value you want, except 2x minus 5 can't be 0. So 2 times x can't be 5, and x can't be 5/2. On a number line, if you can't use 5/2, but you could use anything before or after, we would say from negative infinity to 5/2 in union with 5/2 to positive infinity. Those would be our domain values. For the second problem, I don't see any denominator with a variable in it or a radical. So the domain for the second problem would just be all real numbers. We would say that from negative infinity to infinity. And then the third problem has a radical. So we just have to say that the domain would be when 2x plus 3 is greater than or equal to 0, or when 2x is greater than or equal to negative 3, or when x is greater than or equal to negative 3/2. In interval notation, we would write this from negative 3/2 to infinity. Infinity always has parentheses. We can't use the exact value of infinity because it's just a concept. For problem number 9, we are evaluating functions, and f of negative 1 means you plug in negative 1 for all of the x values. And if we simplify this, we get negative 7, so that would be f of negative 1. And then g of x minus 2 means we plug in x minus 2 for all of the x's in g of x. So instead of saying 2 times x plus 7, it's 2 times x minus 2 plus 7, which would be 2x minus 4 plus 7, or 2x plus 3. And moving on to our last page, problem number 10, it says you invested $35,000 in stocks and bonds, paying 6% and 3% annual interest respectively. If the total interest earned for the year was $1,500, how much was invested in stocks and how much was invested in bonds? So we're going to take the interest from stocks plus the interest in bonds, and together that's going to equal 1,500. Now the way we find interest is we multiply the percent times the principal, or the amount invested. I don't know how much the principal was for stocks, so we could use x, and we know that stocks paid 6%. Bonds paid 3%. Now, I also don't know how much the principal was for bonds, but it would be whatever's left over after we took out the amount of money in stocks. So for example, if we had $35,000 and we had $20,000 invested in stocks, the amount left for bonds would be $35,000 minus $20,000, or $15,000. So the way we figure out the amount of principal left for bonds is we do the total minus the amount we spent for stocks. So now we're set up. We can go ahead and solve. And 3% times 35,000 is 1050 minus 0.03x. Combine like terms. And let's solve for x. So we're going to do 1,500 minus 1050 is 450. And then if we divide both sides by 0.03, 450 divided by 0.03 gives us $15,000. And remember, that's the amount that we had in stocks. That's what we defined x to be. So the amount left over for bonds would be 35,000 minus 15,000, or 20,000. A couple more left. For problem number 11, it says a chemist must mix 5 liters of a 30% acidic solution with some 75% acidic solution to make a 60% acidic solution. How much of the 75% acidic solution is needed? So generally, when we're doing these kind of purity problems, the way I like setting them up is we have the volume, we have the percent purity, and then we get the volume of pure. So for this first solution, we have 5 liters of 30% purity. As a decimal, that's 0.3. And then the amount of that's pure, you would just multiply them. So 5 times 0.3 is equal to 1.5 liters of pure acid. The next solution, we don't know how much we have, so we'll use X for the volume. And we're going to multiply that by 0.75 to get the volume that's pure. So this would be 0.75 times X. And the total would be 5 plus X, or X plus 5. We want to get 60% purity. And this comes out to let's see here, 0.6 times X plus 5. Okay, so we have part 1 and part 2, and then we have the total underneath it. So the way we could handle this problem is to say that the part pure, so part 1 pure plus part 2 pure, is equal to the total pure. So this would be 1.5 liters plus 0.75x liters is equal to 0.6 times X plus 5 liters. Let's combine like terms and distribute. And 1.5 divided by 0.15 is 10. So the answer is, how much of the 75% acidic solution do we need? We need 10 liters of the 75% acidic solution. And then the final problem, we have a rectangle, and the perimeter of the rectangle is 14 centimeters. The length is 3 centimeters longer than the width. So we take the width and we add 3 to that. Find the length and the width. So the way we could finish this is, we know that the perimeter is equal to the lengths added together and the widths added together, or simply 2L plus 2W. If we know that L is W plus 3, and we have the width is represented by W, we can go ahead and set the perimeter to 14 and solve. So 14 is equal to 2W plus 6. And then bringing our 6 over, we get that the width is equal to 2. And if the width is 2, we were asked to find the length. Remember, the length is 3 more than the width, so that would mean the length is 5 centimeters long.